Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss the next part from the chapter structure of atom, and that is electronic configuration. If you remember, in the last class we have discussed the electronic configuration of three atoms. First one was the hydrogen, next one was the helium, and third one was the lithium. Okay, how to draw the electron configuration I have explained to you this with the help of the Bohr's atomic model. Right now, next examples we are going to discuss in today's class. So let us see further examples. Okay, in which the fourth example after these three is the beryllium. Beryllium, Berylium. Be is the symbol for beryllium. Be, capital E small. Atomic number Z is equal to 4. As we know, Z is nothing but the atomic number. It is also equal to the number of electrons, right? Atomic number is nothing but how many electrons are present in that atom, right? Okay, so therefore how many electrons are present in beryllium? 4 electrons are present, right? Okay, so yes, then this one is the nucleus of beryllium atom, in which protons and neutrons will be present. Then this first shell I will draw surrounding to this nucleus. Okay, now the first shell is nothing but the K shell, right? Okay, so shell, its number, and how many maximum electrons we can feel here in that shell. Okay, yes, so it is K shell, which is nothing but the first shell, shell number 1. In shell number 1 we can fill 2n square, that is 2 into 1 square, that is 2 electrons, right? Okay, so let us fill 2 electrons in it, 1 electron here, another here. So out of 4, 2 electrons are filled here. What about the next electrons? So next electron will enter in the next orbital, right? Okay, that is what we do. Okay, so this is the next shell. Okay, this is the next shell, which is nothing but, yes, so this next shell is L shell or second shell, for which the maximum number of electrons will be 2n square. 2 into 2 square, that is equal to 8 electrons. So how many maximum electrons we can fill? Maximum we can fill up to 8, but only 2 are remaining, so one will be here, another will be here. So this is the model, atomic model for beryllium atom, right? Now if you remember, I have told you the electron configuration, it can be written like this: N, S and X. Okay, where N is the shell number in which that electron is present. Okay, N is the shell number. Then S is the symbol of subshell in which that electron is present, that is either S, P, D or F. Okay, S or P or D or F, right? And then X is nothing but the number of electrons in that particular shell. Okay, number of electrons in that particular shell. Okay, yes, now here there are 2 shells, so we have to write down the configuration for 2 shells separately. First of all, for the K shell I will write down for K shell N is equal to 1, right? For the symbol is S and 2 electrons are present, so this is for K shell, right? Then I will write down for the another one, that is L shell. For L shell, the N is equal to 2, symbol is S and 2 electrons are present. So 1s2 2s2 is electron configuration of what? Electron configuration of, therefore what is electronic configuration? 1s2 2s2. This is the electronic configuration of beryllium atom. Okay, do you remember the same thing we have seen for the hydrogen, helium and lithium in the last class? Okay, just take a screenshot of this page first of all. Okay, so after beryllium, let us see next example for electron configuration, and that is boron. The fifth example is boron. The symbol for boron is B. Atomic number is 5. As atomic number is 5, there are 5 electrons present in it, right? Okay, then this is the nucleus of boron atom, right? And then first 2 electron will enter in the first shell like this, 1 and 2, right? So these are the first 2 electrons. So here I'll write down shells, symbol and electrons. Okay, so for the shell number 1, that is K shell, 2n square is equal to 2. Okay, remaining electrons, they will enter in the next shell. Remaining electrons means 3 electrons, right? So they will enter in the L shell. L shell is the second shell, for which 2n square is equal to 8. That means in L shell we can fill maximum up to 8 electrons, right? So 3 will go here. So this is the structure of atom of this boron. Now let us see electron configuration. First of all, let us write down for this K shell. So for K shells, the shell number is 1, symbol is S, and this number of electrons are 2. This is for K shell, right? Okay, now the next is the L shell. Now for L shell, we know there are 2 subshells S and P, right? There are 2 subshells S and P. Okay, the subshell S always contains 2 electrons, P contains 6 electrons, right? Okay, yes, that is the capacity of these subshells. We have seen this part also previously. So next for L shell, the next electron will enter in the S shell first of all in a sequence. So shell number is S2, symbol is S, and 2 electrons will enter here. 2 plus 2, 4 electrons are entered here. What about the 5th electron? Here we cannot add 3, right? Because that is the capacity of S subshell, only 2. So next electron will enter in P, right? So this P belongs to the shell L, that is second shell. So its symbol will be 2p, right? 2p, and there is only 1 electron here, so it is 2p1, right? So therefore for L shell, what we have written, the configuration 2s2 and 2p1, right? Okay, yes, therefore what is the final electron configuration of boron? 1s2, 2s2 and 2p1. This is the electronic configuration of boron atom, right? Yes, so now let's see the next example. Next example is of carbon. Carbon. Okay, now for carbon, the atomic number is 6, symbol is C. Atomic number is 6 means there are 6 electrons present in it. So this is the nucleus of carbon atom. Okay, then first 2 electron, as usual, they will enter in the first shell, right? So here I'll write down about the shells and the number of electrons in them, maximum number of electrons. So first of all, for K shell is nothing but the first shell, 2n square is equal to 2, and for L shell, which is the second shell, 2n square will be equal to 8, right? Now K shell is further divided into only S subshell, whereas L shell is further divided into S and P subshell, right? In S subshell, always there are 2 electrons. Okay, S subshell, only 2 electrons always. Okay, whereas in P subshell, there can be 6 electrons, right? These things also we have seen already in the previous class, right? Okay, now let us fill first of all 2 electrons in K shell, right? Yes, so that is done for K shell. Next I will draw the second shell, right? L shell. Now here in L shell, first of all, there will be, yes, so here in L shell, 4 electron will enter, 1, 2, 3 and 4, right? Okay, let us see electron configuration. First of all, I will write down for K shell. It is very simple, 1s2, right? Okay, 1 is the shell number, S is the symbol, 2 is the number of electrons in it. Now I'll write down for L shell. In case of L, there are two orbital, one is 2s, another is 2p, right? So first of all, we'll fill the electron in 2s. 2s capacity is 2 electrons only. So out of 6, 4 electrons we have filled. Remaining are 2, that 2 will enter in 2p. So this is nothing but the L subshell, right? So what is the final electron configuration of carbon atom? 1s2, 2s2, 2p2. Okay, so this is the electronic configuration of carbon atom, right? Okay, now take a screenshot of these two examples first of all. Okay, now let us see the next examples. The sixth example after carbon is seventh example is nitrogen. The symbol for nitrogen is N. Atomic number is 7. That means there are 7 electrons in nitrogen. This is the nucleus. Okay, then first of all 2 electrons of nitrogen will enter in the K shell like this. Then remaining 5 electrons they are going to enter in the next shell. 1, 2, 3, 4, 5. Right? Now let us see the electron configuration. First of all, for K shell is going to be same for all. Then for L shell has 2s and 2p. Right? Okay, so this is for L subshell. This one is for K. For S always 2 and remaining 3 electrons will enter in 2p. Right? So what is the electron configuration for nitrogen? 1s2, 2s2, 2p3. Right? Okay, after nitrogen let us see the next example. 8th example is oxygen. For oxygen symbol is O, atomic number is 8. That means there are 8 electrons in it. Okay, so out of 8 electrons 2 will enter in K shell and remaining 2 will enter in L shell. Okay, so this is the nucleus of oxygen atom. This is the K shell. Okay, and this one is the L shell. Okay, then electrons I'll show. First of all 2 electrons will enter in K shell and remaining 6 electrons they will enter in the L shell. Right? Okay, now let us see electron configuration. So first of all I'll write down for K shell it will be 1s2 always. Right? Then I'll write down for L shell. For L shell there are 2 orbital, 2s and 2p. The capacity of S is 2 always. Capacity of P is 6, but here there are only 4 electrons in 2p because total electrons are 8. So what is the electron configuration of oxygen? 1s2, 2s2, 2p4. Right? After oxygen let us see the next example, and the 9th example is of fluorine. The symbol for fluorine is F, atomic number is 9. That means 9 electrons are present here. So this is the nucleus, then this is the shell number 1, then this is the shell number 2, right? Okay, now there are total 9 electrons, right? Okay, now how the 9 electrons are filled? Again the same way, 2 electron in K and remaining 7 electrons in this 1, 2, 3, 4, 5, 6 and 7. Right? Electron configuration first of all for K shell it is as it is 1s2. For L shell 2s and 2p. Right? So this is for L shell. As we know capacity of T is always 2 and capacity of P is 6. Right? But here only 5 electrons are there in 2p because total electrons are 9. So what is the electron configuration of fluorine? 1s2, 2s2 and 2p5. Right? Okay, after fluorine next example we are going to see, and that is neon. Okay, for neon the symbol is Ne. N capital E small, atomic number is 10. 10 electrons are present here. So this is the nucleus of neon atom. Then first of all the K shell and then the L shell. Okay, yes, so first 2 electron will enter in K shell and remaining 8 electrons they will enter in L shell. Capacity of L shell is 8 electrons only, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Right? What we have studied, the capacity of shell and capacity of carrying electrons. Okay, K shell is 2 electron, L shell is 8 electron. That means with the neon the capacity is completely filled, right? Okay, K shell has only s orbital, L shell has s and p orbital, right? In s 2 electron, in p 6 electrons will enter, right? Okay, so let us see electron configuration of the neon atom. So first of all I'll write down for K, it is 1s2 as usual. Then I'll write down about L. L has 2s and 2p. In 2s always 2 electron will go and remaining 6 electrons will enter in this. So this is about the L shell, right? Okay, therefore electron configuration of neon will be 1s2, 2s2 and 2p6, right? Now here you can see the, in case of this, the last electron, that is valence shell, is the shell number 2. Valence shell has 8 electrons in it, right? Valence shell has 8 electrons in it. That means octet is completed, right? We have seen about octet and all. Yes, good evening. Just a minute, I saw your message right now. Yes, hi. Good evening. I hope I'm pronouncing it correctly. It's Jaya Murugan Varadraj, right? So hi Varadraj. So I'm explaining how to write down the electron configuration of elements. I think you have joined 5 minutes before or more than that. So yes, so I'm up to neon I have explained right now. Okay, up to neon I have explained. Neon is having the atomic number 10. Neon is one of the inert gas. Okay, that is noble gas, which we have discussed in the previous class. Actually, if you go on watching the recorded sessions for this chapter, you will be able to understand what is the noble gas or inert gas. So neon is one of that. So neon has 10 electrons in it. 10 electrons can be filled in the atomic orbitals like this. Okay, yes. So up to this, what you can do, you can just go on taking screenshots. Okay, yes. So I up to oxygen I had nitrogen I have explained. So from oxygen onwards, you can just take screenshots of these 3 elements, and the next element, sodium, when I will explain to you, then you will understand this thing completely. Okay, I think you will not be able to see the writings due to the size issue, so I'm increasing the size little bit. Yes, you can just take a screenshot of these 3 electron configurations one by one, then I will explain the next element to you. Okay, and if you have any another doubt related to this, please let me know in the chat box. So just for your information, Varadraj, this is the 3rd chapter from the class 9. After the 2 chapters we have discussed already. So in this chapter basically we are learning the structure of atom, right? So structure of atom, we cannot see the atom by naked eyes, right? We even cannot observe the atom, a single atom, under the microscope, and we can study its structure. So all these things which are given in textbook or all the reference books, all the theories, they are based on the assumptions and some practical or experimental observations also, right? So out of all these, the best model you can say, or the which is accepted worldwide, is the Bohr's atomic model, which is given by the scientist Neil Bohr. Okay, Neil Bohr. So whatever explanation I have written here on the board, it is on the basis of this model of this Neil Bohr, Bohr's atomic model. Okay, yes. So now you can take the screenshot for fluorine. Yes. So what is the idea? Basically, for every atom there is the black portion which I have shown at the center. That is nothing but the nucleus of an atom, right? So as we know, nucleus is the central part. It contains protons and neutrons in it. So where are the electrons then? So electrons are revolving surrounding to the atom, surrounding to the nucleus of an atom, right? How they are revolving? Just like the planets are revolving surrounding to the sun. Similarly, the electrons are revolving surrounding to the nucleus of an atom. So here, as this is a white board, or this is a 2-dimensional board, right? Just like a paper is, it's 2-dimensional. On 2-dimensional things we cannot explain the 3D entities, right? Atom is a 3-dimensional entity. It is a spherical entity, just like a football. You can just imagine football in front of your eyes. Just like football is, at the exactly central portion of football there will be nucleus, and surrounding area there will be the electron present in it, and they are not present at one position. They will never remain at one position. They will continuously go on revolving surrounding to the nucleus. Okay. Yeah, so this is the basic idea about the atomic model. Now according to this scientist Neil Bohr, he has just divided these circular paths in which these electrons are moving into the orbitals, right? Yes, so those orbitals I have written over here. Now you can just take a screenshot for neon also simultaneously. Okay, I hope it's done. Now just observe the last example for today's session, which I am going to explain to you. That is nothing but the 11th example, and it is sodium. Okay, we know about sodium very well. The symbol for sodium is Na, N capital A small. Why it is sodium? Why not S? Because S was already taken by someone, that is sulfur. Sodium is called as Na because its another name, its Latin name is natrium. Therefore Na, from its Latin name, they are taken for its symbol sodium Na, right? Okay, atomic number for sodium is 11. As we know, atomic number is nothing but the number of electrons. Therefore in sodium there are 11 electrons, right? How to feel those electrons in the orbital? Let us see slowly. Okay, so first of all, how many shells are involved and how many electrons are present in there, you can see. So first of all, the K shell, which is the first shell in which maximum 2 electrons we can fill. Next is the L shell, which is the second shell in which maximum up to 8 electrons we can fill. And the next one is M shell, and it is the third shell in which maximum up to 18 electrons we can fill, right? In case of K shell, only one subshell is there, S. In case of L, 2 subshells are there, S and P. In case of M, 3 subshells are there, S, P and D, right? Okay. Now as we know, in case of S subshell, we can fill maximum up to 2 electrons. In case of P, we can fill maximum up to 6 electrons. In case of D, we can fill maximum up to 10 electrons. Okay, yes, these numbers are fixed. Okay, let us start with the first shell, that is K shell. In K shell, we can fill up to 2 electrons, one here, another here. That is done for K shell. Next is the L shell. Okay, L shell. In L shell, we can fill maximum up to again 8 electrons, right? So 8 electrons I'll fill 1, 2, 3, 4, 5, 6, 7 and 8, right? 8 electrons in L shell. Obviously out of 8, 2 will go in the this S subshell, 6 will go in the P subshell, right? Then the last one, okay, that is the M subshell. Now in M subshell, how many electrons we can fill? Total 18. But you can see 8 have entered in the L, 2 have entered in the K. Therefore 8 plus 2, 10 are already done. How many is remaining? Just 1. That 1 will enter here. Okay, so this is the structure for the sodium atom. Now let us draw electron configuration. First of all, I'll draw for K subshell, it is always 1s2. Then I'll draw for L subshell, which is 2s2 and 2p6, completely filled, right? Yes, this is for the L subshell. And then I'll write down about the M subshell. Now in case of M, 3s, 3p and 3d are there, right? First of all, electron will enter in 3s. So 6 plus 2 plus 2, 10 are already done, just 1 is left, that will enter here. So as there are no electrons in 3p and 3d, I will just delete it. Okay, yes, so this is the electron configuration for sodium atom. Okay, I can write it down again: 1s2, 2s2, 2p6 and 3s1. Okay, so this is the electron configuration for sodium atom. Okay, I hope you got this, how to write down or how to draw the structure and how to write down the electronic configuration for the elements, okay, atoms of the elements. Okay, yeah, just take a screenshot of this last example. I hope you have taken a screenshot. So before ending the class, please let me know if you have any questions related to this, and if you have any questions, and if you can just note it down on your notebook, and you can ask me in the next class also if you want. Before ending the class, let me just show you about the DPP, daily practice problem. So this is a teacher's portal, similar will be yours. Go to resources, then to writing material, then you can see DPP over here, daily practice problem. Download it, write down the solutions on your notebook, and just upload it on the portal. Teacher will be able to see it and evaluate and let you know the suggestion wherever required. Okay, so that's all for today. Remaining we will discuss, remaining concept from the same chapter we will discuss in tomorrow's session. Thank you so much, students, for joining, and thank you so much for your precious time. All the best to you. Take care.